Welcome to this video to talk about Unit 4, Sections 6.4 through 6.5 on the topic of trigonometry. Two triangles having the same angles are similar. The sides of similar triangles are not necessarily equal. However, the lengths of the corresponding sides of the similar triangles are always in proportion. Consider the following triangles: 3, 4, 5, 15, 20, and 25. The ratios of the corresponding sides are proportional. For example, if I could take the fraction 3/4, that is equal to 15 over 20. 4/5 is equal to 20 over 25, and etc. For example, if I take this side right here and compare it to this side, so if I write it as 3 over 4, then when I take a look on the other side, I have to make sure I take the left side, or the height, and compare it to the base of the triangle. And you can set it up by taking any two sides of a triangle and comparing it to any other two sides of a triangle. For example, I could have said 25 over 5 because I'm comparing the longest side of each triangle, and I could set it equal to 20 over 4, and they should equal each other. For example, find the unknown measure indicated by the variable x. And the two triangles that we have a smaller triangle, 6 and the x, and the bigger triangle, 9 and the 12. If these two triangles are similar, that means that the angles will be the same. So what I would do is I can take the ratio within the same triangle and equal to the ratio of the other same triangle. So I could say 6 over x is equal to 9 over 12. If you take a look at the solution, they have it where the x is on top. If the x is on top, that means the side corresponding to the x must be on top also. Or I can write it as the ratio of 6 to 9 is equal to x over 12, where these two came from the same triangles. And last but not least, I can do it the other way. I can do it where I have 9 over 6 is equal to 12 over x. All four of these would produce the same answer. If you follow what the solution says, x over 6 is equal to 12 over 9. If you take a look at how the solution did it, they cross-multiplied and multiplying the 6 and the 12 together, and the 9 and the x together. And whenever you cross multiply, you put one product on one side and then you put the other product on the other. That's why they have 9x on one side, 6 times 12 on the other. You could flip-flop them, but overall, to get x by itself, you divide by 9, and that's how they get the answer of 8. So let's take a look at this example. It says find a and x. These two triangles are similar because if you take a look at it, the angles are the same. So that means that triangles A, B, C is similar to the triangle. In order to find out the writing of the similar triangles, we want to match up their angles. That means that angle A has two curvy lines to it. That means that corresponds to the Y. B has one line that corresponds to the Z. And C has 3 lines that corresponds to the X. So triangle ABC is similar to the triangle YZX. With that said, if I had to label it, if I have a capital A here, that means I have a lowercase a there. If I have a capital B here, that means that 20 is also lowercase b. And if I have angle C, that means that 17 is lowercase c. We represent the angles by using capital letters. We represent the sides by using lowercase letters. So if you take a look on the other side, that means that the 12 represents the Y, and the 16 represents the Z. So because these two triangles are similar, that means that the sides are proportional. So since these two triangles are similar, what I would need to do is find a triangle that has two sides given. So for example, I have sides B and C, so I can write the ratio B over C. And that corresponds to the side Z over X. Plug in what you know. You know you have 20 over 17.5. is equal to the z 16 over the unknown x. Cross multiply. That will give me 20x is equal to 16 times 17.5. That will give me 280 divided by 20. And x is equal to 14. We can do that again by solving for the a. Now, whenever you're solving for a, because a is part of the first triangle, we want to maybe compare two different triangles together. For example, a corresponds to the y, so I can write it as a over y is equal to b over z. And how do I know what it compared to? Because again, the angles correspond to each other. So side A will correspond to side Y, side B will correspond to side Z, side C will correspond to side X. Plug in what I know. I do not know A. Y is 12, B is 20, and Z is 16. And cross multiply. And A ends up being 15. Let's find H for this triangle. Now this triangle is different in a way, in the sense that the triangles are not separate. It is a triangle within a triangle, which means that they're similar. So if you actually take that second triangle and write it outward, here's your height C, this is B. These angles are the same. These angles are the same, and they both have a right angle of 90 degrees. So that means that they are similar triangles. The only catch with this one is the fact that your base for the big triangle is going to be the sum of 5 and 18, which is 23. So when I'm doing my proportion, if I'm looking for C, I'm going to compare the base of the small triangle with the base of the big triangle. So that's 18 over 23. Since I put the 18 on top, I have to put the C on top for my height. And I want to put that over the height of 10. Cross multiply and divide. And a rounded answer would be 7.8. Suppose that a 6-foot person wishes to determine the height of a bridge above the bottom of the canyon. Find the distance to the bottom of the canyon if AP is 10 feet and PB is 40 feet. So if you take a look at, here's a 6-foot person. That would give you the height of the person. We're told that AP, which is this part right here, is 10 feet. We're given that the other side from PB, this is 40 feet. And we're looking for the height. So let me go ahead and redraw it. Here's my 6-foot person. Here's my 10 feet. Here's my 40 feet. And here's my unknown. We should know that this angle and this angle are equal because they're vertical angles. We know that they both have a right triangle. So by default, the third angle must be equal. Since these two triangles are similar, we can write the ratio of AP, the distance of AP, over the distance of PB is equal to the ratio of the height of the person, AX, over the depth of the canyon, which is BT. Plug in what you know. AB is 10, PB is 40. The height of the person, AX, is 6. And the depth of the canyon is the unknown, so I'm going to call that, just leave it as BT. Go ahead and cross multiply and divide by 10. So the depth of the canyon should be 24 feet. A triangle in which one angle is a right angle or 90 degrees is called a right triangle. The side opposite of the right angle is called hypotenuse. And the remaining two sides are called legs of the triangle. The sides of the right triangles are generally labeled using lowercase letters, and the angles are labeled with corresponding capital letters. When labeling a right triangle, we usually use capital C to represent the 90-degree angle. The other two angles are labeled A and B, and they could be switched. It doesn't really matter where you locate them. The side C is directly opposite from the 90 degrees. It is always side C. It is always hypotenuse, which is by default the longest side of a right triangle. If the hypotenuse is not the longest side, then we do not have a right triangle. Now the other two sides are called legs. Again, they could be switched. But if I let this angle be angle A, the side directly opposite that would be side A. And if this is angle B, the side directly opposite of it would be side B. For any right triangle with the hypotenuse labeled C, we use the formula a squared plus b squared is equal to c squared. Note that it doesn't matter what letters are used to label the triangle. The critical feature is that the hypotenuse is alone on one side of the formula. This theorem is useful for finding one side of a right triangle when we know the lengths of the other two sides. Another way of saying this, instead of using the letters, we can say leg squared plus leg squared is equal to hypotenuse squared. Now it says to find the length of the missing sides in a right triangle. So here I'm given one side is 12, the other side is 13, the other side is A. Knowing the labeling that we know, we always label the right angle to be C. That means that 13 is side C. We have side A is the unknown. That means on top must be angle A. And by default, the third angle is B. That means that 12 is equal to B. Using the formula, because it is a right triangle, a Pythagorean theorem, a squared plus b squared is equal to c squared. Plug in what you know. And whenever you take the square root of an equation, you must do it to both sides. Another approach to this problem is another way to take a look at this problem is, again, starting off with the Pythagorean theorem, is if you want to go ahead and solve for the missing variable, we can actually subtract b squared from both sides. That gives me a squared is equal to c squared minus b squared. And then take the square root of the whole difference on the right hand side. And that will give me the value of a is equal to the square root of c squared minus b squared. If you are going to use this method, make sure you do the parts underneath first before you take care of the square root. So that gives me a is equal to 13 squared, which is 169 minus 144. And that would give me the square root of 25, which is 5. So what I want you to do for this one, I want you to pause and see what you can do with this one. I want you to find C of the right triangle. Because this is a right triangle, we do have Pythagorean theorem. We do have a squared plus b squared is equal to c squared. You're given a is 24. You're given b is 7. You do not know the c. Because the variable is already on one side, you can go ahead and simplify it. 576 plus 49. And then take the square root. And that will give you a c value of 25. Also, what you could have done is going back to the original formula. If you want to go ahead and get c by itself, take the square root of both sides. So the square root of a squared plus b squared is equal to plain c. Then plug in your numbers. 24 squared plus 7 squared. A common mistake that people will do is they want to individually take the square root of the two numbers. You cannot do that. You got to find the sum first and then take the square root. Either way, you get the same result.